Let's solve a given rational equation. Here we have 1 all over x plus 1 minus 3 all over 2x is equal to 4x squared. So here, when it comes to solving a rational equation, there are some ways on how to solve it, but it depends on a given problem. So since I mentioned some ways, so it's also an implication that we could use some, other methods or ways that would solve the problem either conveniently or inconveniently. So here's the thing. For us to avoid confusion and complication, I'm going to solve a rational equation by the common method. Like usually, how are we going to solve the rational equation? Like no techniques, no shortcut methods, because those shortcut methods, depends on, it depends on a given problem. Because if the problem is simple, maybe shortcut method will do. But for this case, to avoid any complications, to avoid any confusions, let's do it in a common way. Like, what's the common method in solving a rational equation? The common way here is you need to find the LCD, right? LCD is basically the least common denominator. What I'm trying to say here, it's like, you see this? You see these denominators? We're going to get the least common multiple of it, okay? The question is how to get the least common multiple. I'm going to show it to you later, all right? Why do we to find LCD? The reason why we do that, we're going to do that because once we found our LCD, we're going to multiply to this equation. Why do I mean by multiply to the equation? What I mean is you're going to basically multiply both sides so that the result would not only have the denominators cancel out, but you will have a simplified equation. All right? Again, why do we need to use LCD? We need to use LCD so that if we're going to multiply both sides of the equation, the denominators will cancel out and we will have a simplified equation, right? So what would be the LCD? So the LCD here is simple, okay? First, you list all the denominators given in the equation. So we have three denominators. We have x plus 1, 2x, and 4x squared, right? Now, after we list all of the denominators, we're going to get the factors. No, wait. We're going to factor them until they're no longer factorable. So you see this x plus 1? It's just x plus 1. X plus 1. Or you can put parentheses beside it. But yeah, it's just x plus 1. All right? 2x is just the same as 2 times x. 4x squared is just the same as 4 times x squared. Or remember that 4 is just the same as 2 times 2, right? Or another way, it's 2 squared. Okay? 2 squared is just the same as 2 times 2. Point being, we can replace 4 as 2 squared. So we will have 2 squared instead. Now, before we proceed to the next step, let me explain why we have x plus 1 only. If you have a denominator in which it does not only consist one term, but more than one of it, like for example, here in this case, we have two terms, so it's more than one. So how are we going to, factor them? Yeah, how are we going to factor them? If you're going to factor them, you're not gonna factor each of the term. Like for example, what's the factor of x? What's a factor of 1? No. Okay, that's not it. Rather, you're going to factor the group as a whole. By how? By their common factor. Let me give you for example. 2x minus 4. Again, we're going to factor this group as whole. So by how? By their common factor. So you see 2 is just the same as 2x. 4 is just the same as 2 times 2, or 2 squared rather. But I would rather put 2 times 2 here because we're looking for the common factor. Okay? So here, both of them have 2. So we will factor this by 2. So as a result, you have 2 times x minus 2. All right? But here, you see, in this case, you just have x plus 1. You just have x plus 1. So what's the common factor of x plus 1? I mean, both of them are multiples by 1, like x is just the same as x times 1, and 1 is just the same as 1 times 1. So yeah, both of them have 1. So if you factor out 1 here, it's just 1 times quantity x plus 1. And 1 times x plus 1 is just x plus 1. So basically, no changes. They're just the same. You know what I mean? So yeah, point being, if you're going to factor a group of terms, base it from their common factor, not one by one, right? Now, okay, let's go back. We factor all the denominators until they're no longer factorable. So what's next? We're going to get what do they have in common, at least by basing it on two denominators. Okay? Again, we're going to get the common factors at least by basing it of given two denominators. Okay? Is that the right way to say? Basically, just look at here, then take a look. Like, are there like terms here that are the same? Like common, basically. So actually, we have, and those are 2 and x. 2 and x. So 2x and 4x squared have something in common, and that is the 2 and x. Now, here's the thing. If they have something in common, what are we going to do? If they are exactly the same, just copy them. Again, if they are exactly the same, we're going to copy them. So if both of them are 2, I don't mean 2 and 2 squared, I mean both of them are 2, then we will put 2. And likewise for x here, if they both are x, not x and x squared, both of them are x, then we're going to copy x here. That's it. But you see, it's not that way, it's you're going to take a look closely. Yes, they have the same factor. They have 2, they have x. But the only difference here is that they have an exponent. And that exponent is not the same as the exponent given for 2x. You know what I mean? Basically, we have 2 and 2 squared. We have x and x squared. So we don't just simply copy them. All right? So in this case, what are we going to do? Since they are not the same because of the exponent, then we will disregard the one that has the least exponent and just bring and just copy the one that has the largest exponent. So in this case, we will disregard 2 and just copy 2 squared. So you will have what? 2 squared. Okay? Likewise for x. Okay, we have x and x squared. So we will just disregard x. Okay, and just copy the one that has the largest exponent, which is x squared. That's it. There you go. All right. Now we proceed to the next step. And what would that be? Copy the other unique factors, or basically factors that are not the same. So we have x plus 1. So we will have times x plus 1. Then after that, you multiply them together. By multiplying them, you do not need to expand it. Like what I mean by expand is you're going to remove the parentheses. Okay? No need. Okay? For now, no need. Just multiply them by combining them together. So 2 squared is again the same as 4, right? So we can rewrite as 4 times x squared, 4x squared, times quantity x plus 1, 4x squared times quantity x plus 1. And what will be the result here? That will be your LCD. So your 4x squared times quantity x plus 1. That's it. Okay, so now I'm going to erase this because we're going to proceed to the next step here. Okay, after we found the LCD. After you found your LCD, you're going to multiply this on this equation. So you're going to multiply the LCD on both sides. So you will have 4x squared times quantity x plus 1 times quantity 1 all over x plus 1. minus 3 all over 2x is equal to 3 all over 4x squared. Okay, times 4x squared times quantity x plus 1. That's it. Now, let's combine them all together. Let's start first on the right side. Okay, let's multiply the right side first. Okay, you have 3 4x squared times 4x squared times x plus 1. So if you're going to combine, if you're going to multiply them, it would look like this. 3 4x squared times 4x squared times quantity x plus 1. It would look like this. You know what I mean? So in this case, you can simplify the problem easily. Okay? Because here, we have 4x squared below and 4x squared above. So we can just cancel it. So if I'm going to cancel 4x squared below and 4x squared above, what's left is I have 3 and x plus 1. So I will have 3 times x plus 1. Okay? 3 times x plus 1. There you go. Okay, let me erase that. Okay, now we will proceed to the left. Okay? Now, as you can see, we have more than one term. We have 1 all over x plus 1 and 3 minus 2x, right? So we're going to multiply this to each of the terms. Okay? Multiply the LCD to each of the terms. So let's start first with the first one, 1 all over x plus 1. So 4x squared times x plus 1 times 1 all over x plus 1. So here, if we're going to combine them together by multiplication, we will have like 4x squared x plus 1 times 1 all over x plus 1. Here we can simplify by cancellation because both of them have x plus 1 below and beside it. So cancel out the x plus 1. What's left is you have 4x squared and 1. So 4x squared times 1 is 4x squared. So you will have 4x squared as a result. Okay? Next, you multiply the LCD to the next term, which is negative 3 all over 2x. So, in here, again, if you're going to multiply them, it would look like this. 4x squared times x plus 1 times negative 3 all over 2x. We can simplify 4x squared and 2x because both of them are divisible by 2x. 2x divided by 2x, 1. 4x squared divided by 2x, you will get 2x. Alright? So what's left is you have 2x times x plus 1 times negative 3. Wait. You will have 2x times quantity x plus 1 times negative 3. So multiply the three terms or three factors together, the result would be negative 6x times quantity x plus 1. There you go. Before we proceed, I would like to give an explanation. Why is it that when we simplify, it's all about below and beside? Actually, it's not only about having a factor below and beside. It could also mean a factor below and a factor above. So if you're going to simplify, by cancellation, just like what I did here, by cancellation, you need like uh, a term or factor below and a factor above. And by above, it could mean like it's literally above the denominator or just beside the denominator. All right. So if if you have that scenario, there you can simplify, okay, by cancellation. Just like what I did here, for example, right? Right? You know how it looks like if I'm going to multiply this together, right? So if you're going to multiply them together, you see I have 4x squared below and 4x squared above, which is to be particular, beside it. So here, I can simplify them by canceling. Okay? So it's about above and below. And that above, it could either be beside the fraction or literally above the denominator. Otherwise, you can't just simply simplify them by cancellation. Okay? So point being, if you want to simplify by cancellation, make sure it has something common below and something common also above. Okay? What above and below have something in common? And that above could either be literally above the denominator or just beside the fraction. Let's go back. Okay? Let me erase this. Now, we're going to find the x. But here, this is not just simply finding the x here because if you're going to take a look closely, we have x squared. We don't just only have x, we just have x squared. So this brings me an idea. Because if we have x squared and x, that means we will either have a quadratic equation, which is ax squared plus bx plus c is equal to 0, or maybe just not quadratic, but it has x squared, as x squared as one of the terms, all right? So in here, in my own theory or my own assumption, our equation would look like this. All right. So in this case, if your equation would look like this after expanding these parentheses and combining all similar terms, that means you're going to find the x, the way how you're going to solve for x in a quadratic equation. Okay? But before that, let's expand this, okay? Let's take a look that if we're going to expand this equation and combine all similar terms, it would be the same as the form like this, okay? Let's take a look, okay? So first and foremost, since we're going to expand, meaning we're going to remove the parentheses. So by doing so is that what we have beside the parentheses, you're going to multiply it on there. For example, negative 6x, right? That's beside x plus 1. So you're going to multiply what's beside it by negative 6x. So negative 6x times x, negative 6x times 1. All right? So in that case, negative 6x times x will give you negative 6x squared. And negative 6x times 1 will give you negative 6x. That's it. Then, okay, we will do the same thing on the right side. We have 3 beside the parentheses. So we will distribute 3 here. So 3 times x is simply 3x, and 3 times 1 is times 3. Okay. Oh, wait. Yeah, right, right. Yeah, I'm correct, actually. Am I right? Yeah, 6x. Okay, good, good. Now, what are we going to do? We're going to combine like terms. So what I'm going to do here is I'm going to group all the terms here to the left. Okay. So I will have 4x squared minus 6x squared minus 6x minus 3x minus 3 is equal to 0. 4x squared and negative 6x squared, both of them are the same because they're like terms or similar terms because both of them have x squared. So I can combine them. So I will have negative 2x squared. Negative 6x and negative 3x, both of them have x, you know. So combining them will give you negative 9x. And here I have a negative 3. Negative 3 is just a lonely guy, right? It doesn't have a partner. It just exists as a constant term. So we're just going to copy negative 3. And now take a look. See, look at this one. This is just the same as this one. So in this case, my theory or assumption was right all along. We're going to solve for x by solving a given quadratic equation because this is what you call a quadratic equation. You will know if it's a quadratic equation if you have x squared and what equals 1? X squared and at least x what equals 1? Wait, wait. You will know if it's a quadratic equation if your highest exponent is squared and you have x squared. Okay? So in this case, you have x squared, and that's like the highest exponent. There. It obviously gave us the idea that there exists a quadratic equation. So in that case, how are we going to solve a quadratic equation? So there are two ways. Okay, there are two ways on how you're going. No, three ways actually. Three ways. Three ways on how to solve quadratic equation. One is through factoring. If you think that this quadratic equation can be factored, what I mean by factored, I don't mean just factor them as a whole because of the common factors they have, but rather we're going to factor them because there exist two binomial factors. Like for example, if I have like this, for example, x squared plus 4x plus 3, if I'm going to factor them, the result would be x plus 1, x plus 3. It would look like this. So you have two binomial factors. When I say binomial, I meant two terms. 1, 2, 1, 2. So you have two binomial factors. Okay, and in any trinomial, there exists like this. Okay, there exists like that. Okay, so if you could factor, okay, and it's factorable, expect that your answer is just similar as this. Two binomial factors. All right. However, okay, there are moments where you can't really factor it into two binomial factors. So you can try another method, which is by completing the square, or the backup formula, which is quadratic formula. In my case, I would rather use quadratic formula because for me, I believe that this is not factorable and it would be convenient of me to solve this one by quadratic formula, which is x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. Now, what is your a, what is your b, and what is your c? Remember this one, right? This one, right? This one. Your a is just simply beside x squared. Your b is just beside bx. And c is just a constant term. So, your a here is negative 2. Your b here is beside x, so negative 9. And your c here is negative 3. Then what you have here, you will substitute it here. All right? So negative 9 plus minus the square root of negative 9 squared minus 4 times a negative 2 times c negative 3 all over 2 times a, which is negative 2. Okay, then let's combine them together. So negative 9, that's positive because negative times negative is positive. So 9 plus minus, hold on, plus minus the square root of negative 9 squared is 81, positive. Negative 4 times negative 2, that will give you positive 8. And positive 8 times negative 3 will give you negative 24. All over, 2 times negative 2 is simply negative 4. Now, let's combine what's inside the root. So 81 minus 24, I do believe that's 55. Let me take a look. 81 minus 24. Ah, it's 57. Really? It's 57. All over negative 4. I doubt. Really? 97? 57? Hold on, let me double check. Hello, I'm back. Yes, it is 57. All right. Now let me simplify this one more time because you have a negative sign of 4. It's okay, but it would be better if you can just bring it out and put it beside the fraction. So you will have x is equal to negative 9 plus minus square root of 57 all over 4. That's it. All right. So there, we could have it this way. This is much better than having a negative sign on the numerator or denominator. Now, you have plus minus. So that means you have two x values. One is you have plus 57, a square root of 57. You have 9 plus square root of 57 all over 4. And the other is you have negative instead. So you will have 9 minus square root of 57. There you go. All right. Since because you have plus minus, so it's an indication that you have two values. One that has the plus, one that is in minus or negative. So these are your x values. Now here's the question though. Which one of them is the solution? Why? Why do I need to ask that? Because you see, we already found our x. So what is our x? That would be, the solution, right? Well, there is a chance that at least one of them is not the solution. You know what I mean? Like you found your x, but when you substitute that here, it's not the same as not the same as on the right side. What I'm trying to say here is that for you to know if it really is the solution, like x1 is the solution, x sub 2 is the solution is by what? By substituting these x values here. Okay, here. Okay? Then, what if you're going to substitute it on the x, make sure that the result overall would just be the same from the left to the right. Okay? So the question is how? Because if you're going to substitute each of them, like for example, let's start with this -9 plus square root of 57. Substitute it to your x. Let me tell you, it's gonna be hard, you know? Substituting it to the x here, it's hard, right? So if you're allowed to use calculator, sure, no problem. I think it's better if you're going to use calculator. All right. I can do it manually. However, for the sake of the time, I would rather just use calculator. All right. Because if I'm going to do it manually, I have to explain how I did it. All right. So let me just copy this. Okay, here. So if I'm going to substitute x as sorry, there's a fly. X as -9 plus square root of 57 all over 4. In here, let's take a look if we're going to have the same result on the left side and on the right side, right? So let me just give me a moment. According to my calculator, if I'm going to substitute that x value to the left side, I will have approximately 0.0043. Or in other words, this is just basically the same as -3 square root of 57 all over 8 plus 23 all over 8. Right. On the left side, on the left side, okay? When I substitute the x value on the left side, that's the result. Okay? Now, how about to the right side? All right, let's take a look the right side. So on the right side, hmm, on the right side, it's actually the same. According to the calculator, if I substitute the x value on the right side, I will also have negative, wait, hold on. I will also have -3 square root of 57 all over 8 plus 23 all over 8. So they are in fact the same. Therefore, this is really a solution. Right? This is really a solution. But how about the second one? How about like instead of having positive square root of square root of what's that again? Positive square root of 57, you will get negative instead. So minus square root of 57 all over 4. Okay? Let's take a look. Now let's try to substitute it on the left side first. Okay? Let me just erase this. All right. So I got the result. Approximately it's 5.706, or in exact answer, you have um positive 3 square root positive 3 square root of 57 all over 8 plus 23 all over 8. All right. Now on the right side, okay, let's see if they're both the same. It is actually also the same as on the left side. The value is approximately 5.706, or the exact value is also the same as on the left side. So it's 3 square root of 57 all over 8 plus 23 all over 8. All right. You can use your calculator to check these. All right. These. So they are, in fact, the solution for the rational equation. Right. How I wish I could teach you how to do it manually. However, for the sake of the for the sake of the discussion and the time limit of this video, I decided to use calculator. All right. So that's all, guys, and I hope you have learned something in this video. See you soon.